Now that you have designed data architecture patterns for storage, relational databases, backup, and security, you are ready to design the platform that often runs the modern application layer on top of that data. Container orchestration. Kubernetes is not just a technology choice. It is an operating model choice that changes how teams deliver software, how security is enforced, and how reliability is achieved. When you design Azure Kubernetes service correctly, you accelerate delivery with guardrails. When you design it poorly, you create a complex platform that becomes expensive, hard to govern, and risky to operate. With that transition clear, you need to frame Azure Kubernetes Service as a strategic platform decision for leaders and architects. Leaders care because Kubernetes can increase delivery velocity, but it can also increase operational complexity if ownership and standards are unclear. Architects care because Kubernetes becomes a shared runtime that many teams depend on, which means its design influences security posture, cost, and outage impact across the organization. Your role is to make Kubernetes adoption intentional, aligned to business need, and supported by a platform blueprint that scales. With the strategic framing in place, you now introduce the operating model that sits behind Kubernetes success. When you run Azure Kubernetes Service, you are operating a platform product for internal customers, not just hosting containers. That means you define who owns the cluster, who owns shared components, who approves onboarding, and how change is governed. You also define what a workload team is responsible for, such as application configuration, deployment practices, and operational response. Leaders value this because it prevents everybody owns it, nobody runs it. Architects value it because clear ownership is the foundation for secure and reliable design patterns. With the operating model established, you now address the first major architecture decision: cluster strategy. Shared clusters can improve cost efficiency and simplify platform management because fewer clusters means fewer places to apply patches, policies, and monitoring. Dedicated clusters can improve isolation for high-risk workloads, regulated data, and mission-critical services that cannot share failure domains. Your decision is based on risk segmentation, team maturity, performance isolation needs, and compliance requirements. Leaders care because cluster sprawl increases cost and operational overhead. Architects care because oversharing increases blast radius and makes incident containment harder. With cluster strategy clear, you now connect Kubernetes design back to the environment separation discipline you have been building throughout this course. Production and non-production are different risk worlds. Non-production often includes experimental code, debugging tools, and looser change practices, and it should not have broad connectivity or shared trust boundaries with production. Your Kubernetes architecture should reflect that, either through separate clusters or strong isolation controls. Leaders care because non-production compromises often become production incidents. Architects care because environment separation reduces accidental impact and simplifies governance. With environment strategy set, you now focus on networking because Kubernetes networking can quickly become a risk area if not designed deliberately. You design Azure Kubernetes service networking to align with hub and spoke principles, private access patterns, and segmentation. You ensure inbound traffic uses controlled entry points and outbound traffic is governed to reduce data exfiltration and hidden dependencies. Leaders care because network exposure is a common breach path. Architects care because network predictability is essential for stable operations and for enforcing security policies consistently across many workloads. With network foundations established, you now address Ingress because this is how users and systems reach applications running in Kubernetes. Your design provides a consistent approach to inbound application access, including how you expose services, how you enforce security controls, and how you manage routing rules. The leadership goal is to reduce accidental exposure and ensure consistent protection for internet-facing applications. The architectural goal is to avoid each team creating its own inconsistent entry pattern, which increases risk and complicates troubleshooting during incidents. With Ingress clarified, you now focus on identity and access because Kubernetes introduces additional layers of permissions beyond Azure role-based access control. You design access to the cluster and access within the cluster with least privilege and separation of duties. You ensure that administrators do not automatically become application operators, and application teams do not automatically gain the ability to modify cluster-level security settings. Leaders care because Kubernetes privilege escalation can have enterprise impact. Architects care because consistent identity integration supports editability, operational clarity, and predictable onboarding for teams. With identity aligned, you now address workload isolation because a shared cluster without isolation is a high-risk design. You define how workloads are separated into namespaces and how trust zones are enforced so one workload cannot easily impact or access another. Isolation is not only for security, it is also for reliability because it helps prevent noisy workloads from affecting others. Leaders care because isolation reduces the chance of enterprise-wide impact from a single compromise. Architects care because isolation is how you keep shared platforms scalable and governable. With isolation set, you now connect Kubernetes to the secrets architecture you designed earlier. Container platforms multiply the risk of secret sprawl if teams embed secrets in images or configuration files. Your architecture defines how secrets are stored, retrieved, rotated, and audited using the enterprise secrets platform rather than local improvisation. Leaders care because secrets leakage leads to breaches. Architects care because secure secret patterns reduce emergency rotations and improve reliability during deployments and incident response. With secrets handled, you now address observability because Kubernetes creates multiple layers of signals that must be understood together. You need visibility into cluster health, node performance, workload behavior, and application level outcomes. You also need consistent logging and monitoring patterns so incident response is not slowed by missing telemetry. Leaders care because Kubernetes incidents can affect many services at once. Architects care because observability validates whether design patterns are working and helps you continuously improve reliability and cost efficiency. With observability in place, you now design resilience patterns because Kubernetes is often adopted for its ability to scale and recover automatically, but that only works when architecture choices support it. You design for scaling based on demand patterns. You design for self-healing through redundancy. And you design for failure domains so a single node or zone disruption does not take down critical services. Leaders care because resilience protects customer experience. Architects care because resilience patterns must align with broader availability and disaster recovery strategies, especially when workloads depend on external data stores and identity services. With resilience covered, you now address a common misunderstanding. Containers are often treated as stateless, but real systems are not. Your architecture clarifies where state lives, how persistent storage is handled, and how data services are protected and backed up. You also ensure that data protection and disaster recovery design covers the full dependency chain, not just the Kubernetes cluster. Leaders care because data loss is often worse than downtime. Architects care because the separation of compute and state is foundational to stable Kubernetes design patterns. With state management clear, you now talk about cost because Kubernetes environments can become expensive when resource usage is unmanaged. You design cost governance through capacity planning, workload sizing discipline, and clear ownership for consumption. You also prevent container sprawl by defining onboarding standards and shared platform services so teams do not duplicate tools and patterns. Leaders care because cost growth can be rapid and difficult to explain after the fact. Architects care because cost discipline reinforces good engineering practices and keeps the platform sustainable. With cost discipline in view, you now connect Kubernetes back to Azure policy and governance because container platforms must be governed just like the rest of the landing zone. You define guardrails for what can be deployed, how images are trusted, how network access is controlled, and how logging is enforced. You also define an exception process because some workloads have unique requirements, but exceptions must be time-bound and risk-owned. Leaders value this because governance reduces risk without slowing delivery unpredictably. Architects value it because governance preserves consistency and prevents platform drift. With governance clear, you now ground the design in a realistic scenario. Imagine 5 product teams share a Kubernetes platform. One team deploys a workload that is over-permissioned and uses embedded secrets, and the workload is compromised. In a weak design, the attacker pivots to other namespaces, extracts secrets, and impacts multiple services. In a strong design, namespaces are isolated, secrets are centrally managed and rotated, outbound traffic is governed, and observability detects unusual behavior quickly. The incident is contained, the blast radius is limited, and leadership confidence remains intact. This is the difference between we use Kubernetes and we operate Kubernetes as an enterprise platform. Let's now discuss the key takeaways from what you learned so far so you can design Azure Kubernetes service in a way leaders trust and architects can defend. Azure Kubernetes service is a strategic platform decision because it changes your delivery speed, operating model, security posture, and failure blast radius. Success depends on treating the Kubernetes platform as a product with clear ownership, standards, and change governance. Cluster strategy must balance cost efficiency and operational simplicity against isolation needs for regulated and business-critical workloads. And production and non-production separation must reflect different risk profiles. Kubernetes networking must align to private access, segmentation, and controlled ingress and egress patterns. Identity and access must enforce least privilege across both Azure and Kubernetes layers, and workload isolation must establish trust zones that limit lateral movement. Secrets handling must align to enterprise key management and rotation practices. Observability must cover both cluster and service outcomes, and resilience patterns must align with broader high availability and disaster recovery commitments. Finally, cost governance and guardrails are essential to prevent sprawl, reduce risk drift, and keep Kubernetes sustainable at enterprise scale. If you want Azure Kubernetes service to be an accelerator rather than a risk multiplier, subscribe so you can continue through the rest of this playlist and complete the enterprise Azure architecture journey. Like this video, so more leaders and architects learn how to design container platforms responsibly. Comment with your biggest Kubernetes challenge such as cluster strategy, workload isolation, or governance guardrails, and share this with your team so you can align on one Kubernetes platform blueprint that scales securely and reliably.